I'm Dr. Jared Boasen. I'm a guest research associate here at the Tech3lab at HEC Montreal. This video is going to be about EEG analysis. And what you're going to see from now on is a specific kind of analysis to look at frequency bands. And in order to perform this analysis, there are a few very special tools that we need to do it. One is you need MATLAB. So if you don't have MATLAB, you need to make sure you can get it. Student licenses are pretty cheap, so make sure you can get that. The Tech3lab also has MATLAB available on some select computers. The second software you're going to need is called Brainstorm. Brainstorm is free software. You just need to register and then you can download the software. And there's a full online suite of tutorials available for you to teach you how to use this software and how to analyze EEG and MEG brain activity. I highly recommend that you take a look at those tutorials before watching this video. I think it will make it a lot more interesting and a lot more valuable for you when you actually try to do this yourself. So here's an example of Brainstorm already on the screen and a nice topo map of the end result of our analysis today. I'd like to add that the point of today's video is not to give you finite detail about every little aspect of this processing software or of EEG processing in general. What we're trying to do is highlight the key steps involved in a frequency analysis. So I'm going to cover the high-level steps that would happen in such a pipeline, and if you would like to learn more about how to dig into more details, by all means you can check out the tutorials or some of my other videos that go in more depth about how to do this. And in addition, there are many other processing approaches for EEG. We won't be covering those today, such as ERP analysis or looking at Morley wavelets, things like that. Those are out of scope for today's video, but they are also valid approaches in EEG experimentation. So what's on the menu for today is importing our data into the system. Then we're going to check the data for any noise or dead channels. We're going to perform artifact cleaning, looking for physiological artifacts, identifying them and removing them from our raw signal. We're going to filter the data. Then we're going to epoch the data. We're going to divide it into small pieces. And then we're going to do a frequency band extraction using Hilbert transform. And then finally, we'll show you how to normalize the data and perform a basic paired t-test. And in the end, you'll have p-values, which you can use for reporting in a manuscript or your thesis, etc. One final word of caution about this video. We're using completely fabricated data. It's not actually representative of the task that we'll discuss, which is a cognitive load-based task. The purpose of using the data is just to illustrate how to perform a frequency analysis and to run that pipeline in this software. So please don't be confused that the results don't match the literature or that it doesn't appear standard to something you've read before.